Hello, welcome to this video. In this video, we will be talking about Python and how to use itertools, that's the itertools module, to run loops much more efficiently. This is a very strong alternative to using for loops and while loops. When you have very large data sets to work with, it's supposed to prevent your app from hanging. It's supposed to also prevent lagging lagging processes. Right here, we will be working with three different files. So if you want to practice this, you have to create three different files, all in the same folders. You create an itertools.py file. You create a knock underscore verify file. Okay, basically, you just need two files. Now, the third file here that we have, which is patients underscore data.json, is going to be automatically generated by your code. So you need two different files. You need the itertools.py file, which you will create, and you need the knock underscore verify.py file, which you also will create. So what we want to do is look at how to use itertools to run code much more efficiently, because we may be dealing with thousands of data. We may be dealing with, tens of thousands of data for individuals, and it's never a very good method to use ordinary for loops to run this. So the tool Python provides to handle very large sets of data is itertools. An example of a case, a real life example, where so much data needs to be handled is what you have on web pages and sometimes on social media platforms, where you endlessly scroll and then pages are generated. For example, in Twitter or in Instagram or in Facebook, you can keep scrolling and there's going to be no end. You can scroll through 1,000 posts from different users from different pages, and then there is no end. And you also notice that only a certain number of pages or a certain number of posts can appear at a time. Now, to achieve this, you need a tool like itertools that helps you to load a particular number of pages at a time, because all of the pages cannot be loaded at once. That would crash your computer or that would crash your phone. So to be able to load a particular number of posts at a time, for example, 10 posts at a time or 20 posts at a time, a module or a tool like itertools module is used to achieve that. So we're going to look at how we can do that. So first, we want to get the data we will be working with. Of course, we won't be able to type the data for 10,000 patients. So there is another Python tool that we can use to generate the data we want. And the module in Python that we can use to do that is the Faker module. The Faker module is a module that has been created so that people can generate data, can generate data for practice. This data can be used for testing. This data is not going to be real. It's not real. It's not going to contain names of real people, addresses of real people. These bits of data will be generated randomly without regard, without reference to anyone who exists. So if you are trying to work with a very large data set, then the Faker module is the go-to module that's going to help you generate a large set of data that you'd love to use to test your application. So in this file here, we are importing several modules. We're importing JSON, random, date time. From date time, we're importing date time and time delta. And then from the Faker module, we import Faker. We will be using all of these to generate a fake patient identity. Okay, so the kind of data we're generating here is data for patients. We're generating data for 10,000 patients. So we jump into line 10, the description for us says define a realistic pool of Nigerian states and corresponding local government areas for your data set. Now, part of what we're going to generate for each patient is the state of origin and then the local government. We don't have the total number of states here, and we also definitely don't have the total local number of local governments in each state. So when you are trying to work out this on your own, you could actually provide the complete 36 states and then the total number of local governments for each state. This is something you can always get from the internet, I think. So for this, for us to be able to generate random numbers, of course, we know that all of our patients cannot have the same local government areas. They cannot come from the same state, and we cannot type these things manually. So we need to generate them randomly. So our faker module is going to do that for us to be able to generate a random state. Would have to use the random module to do that, and then we can proceed. So we need a pool of states and local government areas that the program can randomly select from. And then we also need a pool of medical data to randomize realistically. Part of the data that the patients will have will be tests that they have run and tests that they haven't run. Also, part of the data they will have will be the ailments that they have treated before or the ailments that they're currently battling. So we need a pool, we need a list of ailments, we need a list of tests that we can randomly select from. So once we have these, we can move on to define a function. Now this function is called generate underscore single underscore patient, and then it takes a patient ID as a parameter. So it means for this function to run, we need to provide a patient ID. So what is this function going to do? It's going to define a state which is going to be randomly selected from the Nigerian geography here. As you can see, random.choice. This random.choice function, the choice function, is going to randomly select. It's going to randomly select a Nigerian state. And then we have the local government area, which is also going to be a random choice from the state that we select. We should know that the state here is a key, and then to be able to access the values of the key, which is the local government, you'd have to refer to the the dictionary and then specify the particular key whose values you want to access. So here we're able to generate randomly a state and here a local government. And then we will be generating other things randomly as well. Sampled tests, we're able to generate tests from the tests pool. These are the tests that have been taken. Okay, sorry, this is just the sample test. So here we have the tests that have been run, and then we have tests that have not been run, still filtered and randomly filtered. And then we are able to find an age for the patient. We're generating age between the numbers 1 and 85. And then the work status, the occupation status of each patient has to be determined. And this is how it's determined. Basically, there are three categories. It's either the patient is a student, or the patient is retired, or the patient actually has a job. So we look at this, we're able to decide this, the program is able to decide this by looking at the age of the patient. If the age of the patient is less than 18, then the patient definitely is going to be a student. So occupation is going to be student, work address will be no address. That's what NA means, because this person is a student, no job, and this person is a minor. So there's going to be no work address. Now, if the person is greater than 65, it is assumed in some societies that people above 65 are retired. Also, there will be no work address because there is no work. And then finally, if the person is not less than 18 and the person is not older than 65, it means that person is still in the active workforce and that person should have a job. That's the assumption. So an occupation is going to be fake the job. Now, you may be wondering where this dot job comes from. This dot job is a method in the faker module that generates randomly a job. It just generates a job randomly. The Faker module has so many methods they can generate anything. Now, this is what we're going to do. I'm just going to come here to show you the so many possibilities of the Faker module. When I add a dot, we will get all of the methods that the Faker module uses to generate things. So the Faker module can generate time patterns. It can generate academic prefixes, probably has to do with professors, professorship. It can generate addresses, it can generate address details, administrative unit. It can generate lots of things, lots of things. It can generate bank country. It can generate basic phone numbers. It can generate binary numbers, birth numbers. It can generate Boolean. Of course, we know Boolean does not exceed two possible values, true and false. It can generate so many things, almost anything you need to do, you need to use any kind of data. It can generate centuries. It can generate let's see, some of these things you may not necessarily know how they work until you try to implement them. It can generate city names, it can generate city adjectives, it can generate city parts, city states, it can generate a lot of things. It can generate a lot of things. So the Faker module is a very powerful one for people who want to test large data sets, and these data sets are going to be generated. They won't be real, so here we generate a fake job. So it's fake the job and it's stored inside of occupation. And then we generate a work address, which is also not real. We use the building underscore number function inside. It's a method in the faker module that generates a random building number. Also, we have a fake dot street name. It's going to generate a fake street name as well. And this is going to be stored inside the work address variable. And then we also want to generate the date between the patient's admission and the current date. So fake the date, start date, and all this. So we are going to generate the data for each patient using this function here, generate underscore single underscore patient. And once we've done these things, we now package this data inside of a JSON, inside of a Python dictionary, because we will be saving this in JSON files. So we need to prepare the data in the right format. So this function is going to return a patient object, which will have the patient's ID, the name, the age, the admission date, the ailments, the tests that have been run, the tests that have not been run, the next test, the surgery schedule, the next of kin, the occupation, residential address, work address, state of origin, and local government area. Now, for the next of kin, a fake name is going to be generated, and a fake phone number is also going to be generated for this person. So here we are just looking at how we're going to generate the 10,000 patient data that we are talking about. Yes, so that's the function. This is the function that's going to help us generate the data for a single patient. So to be able to generate 10,000 data for 10,000 patients, we have a function which says create underscore JSON dataset. Now, this is going to run based on the number we place here. So if the number is 10,000, it's going to run this generate underscore single underscore patient function 10,000 times. As it runs it 10,000 times, we are able to create data for 10,000 patients. So what it does is first it prints a message out to the terminal that says generating total underscore patients, patient profiles, please wait. Of course, we know that the value for total underscore patients is 10,000. So what we should find is generating 10,000 patient profiles, please wait. And then we are able to, you know, store these patients' data in a patient's list. We're able to store this in a patient's list. Yes, that's what we're going to have here. This is a generator function that's going to run 10,000 times. This generator function is going to run 10,000 times. This brings to light how powerful and how fast computers can be. And once these data have been generated, they get stored in a list. And then we open a JSON file called patients underscore data.json. We write into the file and we encode the data in this format UTF-8 as JSON file, and then we dump this data in a JSON file. Finally, we print success dataset saved as patients underscore data.json. I already have that JSON file generated here, which is what I have here. This is what I have here. So my JSON file already exists. So what's going to happen is after you're done with this code, you need to run the script so that you can generate your JSON file, your JSON data. And after you've been able to generate your JSON data, you can now go on to this second file, which is knock underscore verify.py. This program is trying to verify the phone number of a next of kin. That's a knock next of kin. So this program is going to verify the phone number of a next of kin. So what we're going to do first here is define a function. So we import the JSON module. We also import the itertools module. So this is where we're actually going to use the itertools module to carefully check for data in the 10,000 patients. Check for data, yes, in a JSON file with 10,000 patients. And like I said, you cannot load all of these at once. It's going to cause significant damage to the progress of your program. Your program is likely going to slow down and probably crash if the data you're dealing with is very huge, very large. So this itertools module is going to prevent that from happening by fetching a certain amount of data first, not fetching all of the 10,000 patients. It's probably going to fetch 10 patients at a time or 20 patients at a time so that your program will have enough leverage to run and not crash. So the first thing we do here is to clean the phone number that is entered. The receptionist, probably a receptionist, is going to be the person who enters this number, and the system is going to check. So we're going to extract and join only the digits from any string. We extract the string, we extract digits from the string, and then we join them together. Now, why are we saying this? Sometimes a string may, for example, now it says a string may contain something like Agnes, Van's wife, dash 000. So what this function is going to do is going to remove all of these other characters. It's going to remove Agnes, Van's wife, and it's going to pick only parts of the string that pass as digits. That means it's going to work with 08031234567, and it's going to remove every other part. So that's what this function is meant for, because it's supposed to look up this number in the patient's data and confirm that this number is the full number of a next of kin. So here, if not text string, simply meaning if this variable here doesn't have any data, doesn't have any character in it, then return an empty string. Now, if it has a character in it, we're going to return this, the result of this. And the result of this is a generator function, as it is. This is a generator function for char in string, text underscore string. If the character is a digit, we return the character and then we join to an empty string. All right. So what this does is this is exactly what actually filters out every other kind of character, but retains only the digits in your string. And then we have another function. So this is going to return the full number plainly. And then we have another function that actually verifies the contact. So this is the function that verifies the contact. And how does it do that? It tries to open this file, the patients underscore data.json file. It tries to open the file. Of course, we provide a file path. It takes a parameter that's the file path. So if we come down here to see where the function is invoked, the file path is provided, and that's what the function is going to work with. So it takes that file path, it tries to open it. It's a JSON file, so it tries to open it, tries to read, provides the encoding. Then it tries to load the data in that JSON file by using json.load. Now, listen very carefully. If your file is not a JSON file, this is not going to work. It's going to return an error. So it tries to read the data in this file, and yes, it loads it. It's of course it's going to be a list of patients, so it loads it here. Now, if this fails, that's why we have the try except block. If you remember carefully, the try except block is meant to help us write bulletproof code. So if there's an error in our program will not crash. So it tries to open this file. If this file exists, it's going to successfully open the file, and then the accept block is not going to run. We're just going to move directly to user underscore input. But if this file doesn't exist, then the accept block is going to run, and it's going to print error database file JSON underscore file path not found, and then it's going to return nothing. But if this file exists and if we successfully open the file, then we can now collect the user input, which is going to request, it says, enter the next of kin phone number to cross check. It's going to strip this of any spaces. That's what the dot strip method is. It's a string method. It's going to remove any spaces that you have to the right and to the left of the data you provide. And then it's going to call the clean underscore phone function. Yes, we've said this clean underscore function is going to remove any other thing you type and return just the digits. So once it does that, it's going to store the digits in target underscore phone. And then here we have an if statement which we're just checking that there actually is a phone number. So if there is no phone number, that's what we mean by if not target underscore phone. It's going to regard that as an invalid input and then ask you to enter a number containing digits. Now, if this is not the case, then this is going to run. It's going to print scanning 10,000 records for next of kin contact matching user underscore input. It's going to match what you type here. And then we have a variable called batches, which is a data structure. At least it's an empty list. This is where we're going to store the matches that we have. So for example, if we have a person who is next of kin to multiple people, then the data for the multiple patients will be stored in these matches. So here we're going to use itertools to repeat to zip the target phone number against all records. So that's what we have here. It's going to repeatedly zip the target phone number against all records. So for patient target in zip, for patient target in zip, patients itertools.repeat target underscore phone. Yes, this is what's going to happen. And now we're going to get the string from the next of kin. If we return to itertools here and come down to line 70 where we have next of kin. Next of kin is just a string. It is a string that has three bits of data in it, three kinds of data in it. It takes the name of the next of kin, it takes the relationship type of the next of kin, and it takes the phone number. So it's going to take that, store it here, and then again we call the clean underscore phone knock underscore composite underscore string. So what's going to happen is it takes the string for the next of kin, which we know contains not just the phone number, it contains the name of the next of kin and also contains the relationship type. And what we need to compare is just the phone number. So it's also going to strip all of those characters and return only the digits in the phone number here. So this is the record underscore phone, which is going to be matched against the user, which is going to be matched against the user input. So if target in records underscore phone and target is not equal to an empty string, matches.append patient. So finally, we're going to print the patient's data if we find that the phone number that has been entered actually matches the phone number for a next of kin, then we will be printing the patient for whom that person is a next of kin. So the primary part here is in line 37, where we use itertools.repeat. Itertools.repeat. So itertools.repeat is not going to allow you load the 10,000 patients at once. It's going to just help you map the patient. These are variables you should know. Patient is a variable, target is a variable. So it's going to help you map patients and the target phone to these variables here, and it's going to do it one after the other. So this is going to prevent your program from crashing. So again, remember that you need to define two files. First, you define the itertools.py file, and then the knock underscore verify.py file. First, you need to run the itertools.py file so that you can generate your 10,000 patient data. If you want more data than 10,000, then you can actually change the value here in line 78. And okay, no, you can actually change the value here in line 92. If you want to generate 20,000, and you want to generate data for 20,000 patients, you can actually do it here. You can also generate data for any kind of person you want or any kind of data you want. You can generate data for companies. You can generate data for a business. You have to specify the aspects of the data that you want to create. If you're creating data for for companies, you have to provide locations and other things that the fake module is going to work with. All right, so try this out and see how it works. Then also try to create something of your own, slightly different from this, so you can actually look at a very large examination, a national examination, where you can generate data for a large examination. You'll be generating data for students' names. You'll be generating data for the scores, probably the averages. You can actually look at a program that is able to analyze the performance of students across the nation or across a continent. We know that national exams always involve a very large number of people. We have the UTME exams involving, I think, over 2 million people this year. So if you're actually running something, writing a system that is able to analyze things in that area of study, you can actually generate data, fake data, and use it to practice and all that. So try to practice this and see how it works.